So today we have a couple of hours to discuss eccentrically braced frames. I hope you'll find it informative and perhaps entertaining. I would like at the end of this presentation for you to be able to understand the principles of the ductile design of eccentrically braced frames, understand some of the practical considerations that we have in the design of this system, and know the appropriate applications for this system. So we'll talk a little bit about how and what sorts of buildings eccentrically braced frames are used. We will cover the principles of ductile design of steel structures very briefly. We'll discuss what makes an eccentrically braced frame an eccentrically braced frame, and a spoiler alert, it's the eccentricity. And then we'll go into the design requirements for eccentrically braced frames. All right, so let's first look at some applications. They're used in all over the world. They're used a lot in low-rise buildings. You can see a couple of examples. They're used in tall buildings and other large structures, especially in seismic zones. It's a pretty robust eccentrically braced frame here with wide flange braces. We're building here. And also, to a degree, used in retrofit applications. This is the Starbucks headquarters in Seattle. So, eccentrically braced frames are in many ways comparable to buckling restrained braced frames. They have similar design values, the R factor, for example, similar lateral stiffness and the like. They're a good thing to consider as an alternative to special concentrically braced frames, especially in some of the cases where the special concentrically braced frame ends up being kind of expensive because of some of the design requirements. The eccentrically braced frame has excellent ductility. It has a somewhat better or higher R factor than the special concentrically braced frame, and it also has a longer period, and that's reflected in the approximate period that's used in the code equations. So here we also can consider the eccentrically braced frames in the lower seismic design categories as an alternative to an R equals 3 system. The same advantages hold, that the better R factor and the longer period tend to have much lower, result in much lower design base shear for the eccentrically braced frame. So in this diagram here, the solid red line would be a code constructed spectrum for the special concentrically braced frame with an approximate period drawn in for a particular height of the structure. So using the code equations with an approximate period, you would get a fairly high base shear for the special concentrically braced frame, the SCBF. For the same height structure with the higher R factor of the eccentrically braced frame and the longer approximate period reflected by this factor C sub x, the period is 50% longer. The R factor is a reduction of, you could say, 33%. And combined, those two things might result in a base shear that could be about a half in this area of the spectrum for the eccentrically braced frame compared to the special concentrically braced frame. So that could be quite a lot of savings there. If R equals 3 were permitted, for example, in seismic design categories B and C, the eccentrically braced frame compared to the R equals 3 braced frame would be a reduction probably of a factor of 3 or so. So the eccentrically braced frame can be a very economical alternative to concentrically braced frame structures. The eccentrically braced frame has some expense associated with it. The braces would be perhaps a little bit heavier than a concentrically braced frame brace. The beams might be heavier, except compared to a chevron configuration for a special concentrically braced frame, those beams end up being very heavy and very expensive. But the chevron beam does, the eccentrically braced frame beam does tend to be a little bit more expensive than other SCBF beams, partly because of the stiffener requirements that we'll cover later on in the seminar. So those are the costs of the eccentrically braced frame, but the savings come in perhaps lighter columns required for the eccentrically braced frame. A little bit more of the overturning is handled in the braces, and of course, as I pointed out, the design base shear is a lot lower.